Okay, so welcome to this tutorial, and of course in this video we're gonna be looking at partial derivatives. So for a function that is involving x and y, we say that the partial derivatives of this, that is one with respect to x, is going to be written as x comma y. So using the limit definition, this is gonna be the limit as h approaches 0 of a function f of x, so plus h then y minus f of x comma y, then divided by what, by h. Then that with respect to y is going to be x comma y, like that. Then this the limit of h as we approach it, as we approach 0 of, that is f of x, then I have, that is y plus h, like that, minus f of x comma y, then over what, over h. So these here will be the partial derivative for a function that is involving x and y, a function of two variables. So if a function is of greater variables, like the one that is what, so you just extend, that is going to be what, for 3. Okay, so this is how you would what you denote. So now another notation that could be used, is, you could see this to be written as partial of f with respect to what, to x. So this is the partial derivative of x, of what, of x, of the function f with respect to what, to x. Then also for y, that would be partial of f over partial of what, of y, like that. So this here is going to be what, the partial derivative. So what is happening when you're doing the partial derivative is you're just going to be uh, you're just going to be differentiating. So in this case for x, the part which has what, the x variables, and treating the other variables, whether it be y, it be z, whatever other variable is going to be there, you treat them as constants. So you only differentiate the part that has what, that has x, then you treat the rest as what, as constants. Same when you're finding this here, you do the same thing. You're going to be treating all other parts, meaning of x, you treat them as constant, then you only differentiate what, that with respect to what, to y. So now how are we going to answer these questions here? Okay, so let's go straight into answering these questions here. So you have the first one is, so they're telling you to find the partial, so the function has been written in terms of what, of w. So another way that which for f which could have been denoted is, if we say z is equal to, that is f of x, then you have y like this. So meaning this would be the same as you taking partial of z over what, partial of what, of x, like this. So now in this case it has been written as w now. So w is what we are looking at. So here you're just going to say that this here is going to be, so w, so you have w, then you're differentiating this respect towards to x. So you're taking the partial derivative of this. So what is going to be the partial derivative of this? So I can write for the first one, that is part a, which we're looking at, I can write w like this. So dividing that as z cubed, I'm going to have x over z cubed, like this, then plus y squared over what, over z cubed. So that way you see that this part here, this entire part here, does not have an x. So it's not going to concern me in the first one, which I'm going to find here. So the partial of w with respect to x, so this is going to just be, I take this part here, so I just differentiate that x there. So I differentiate the x there, and I just get that to be 1 over the 1 over z, what, z cubed. Since this here, when I differentiate x by power rule, I know that I'm just going to get what, so here it's the power 1, of course, so minus the 1 there. This gives me 0. Anything raised to the power 0, you get what? You get 1. So that's the 1 there over what? Over the z. So now I do the same for the next one. So you get partial of, then partial of w, then partial of what? Partial of y. So this here is going to be, so I look at which one has y. So this, only this part has y. So I forget about this part here. So that one with y, meaning I differentiate that. Differentiate the y squared, meaning I'm going to get 2y, then over what? Over z cubed, like that. Then I get the last one, which is partial of w, then with what, respect to z there. So I get, so we see that it's dealing with partial, the z part. So the z part is just the whole thing. So I get relating to the original one, the way it is written. So you have it being written as that's w, then you have that is x plus y squared over what, over z cubed. And this of course can be written as x plus y squared. Then this here is going to be written, this z here I can just write it as what, as z to the power what, negative 3, like that. Then I just differentiate this. So I see that this is the only part that has what, that has the z. So what do I get when I differentiate this? So I have x plus y squared there, then I differentiate that part there, I'm just going to get negative 3. Then you have z by power rule, of course, then I just have negative what, negative 4 there in the power. So rewriting this, I just have x plus y squared, then this here is going to be, of course, the 3 will remain on top, the negative 3. Then this z, I can just write it here in my what, in my denominator as z raised to the what, to the fourth, and like that I found the what, the partials which I am looking for there. Okay, let me do the next one. So the next one, how does the next one follow up? So for the next one, you have w being given as ln. So you have ln, then you have x cubed y squared, then that plus z. So now the first one, partial of w, partial of what, of x. So first of all, remember you're dealing with ln here. So ln, how do you differentiate that? You get the whole function, that is this which is inside there, that is going to be your what, your denominator. So you write that as x cubed over y squared, then plus what, plus z. Then now you differentiate this, now is what is going to be in your numerator. Differentiate this with respect to what, to the variable which you're looking for. And in this case we're doing with what, with x. So this x cubed, I differentiate the x cubed, I'm just going to have 3 by power root 3, then that will be x squared, y what, y squared, like that. So I've differentiated the first one. The next one is partial of w, partial of y. Then this here is just going to be, so with respect to y, so the denominator in this case is not going to change for all this. It's going to be the same. What's going to be changing is the numerator, because I'm differentiating respect with what, different variables. So now it's y. So with y, meaning I'll get what, I'll get 2 x cubed, then I get what, I get y. Then the z there, I won't touch it because that has no y in it. I do the same now, partial of w, partial of z, and this here down there I get x cubed y squared plus z. Then I'm going to have that, I differentiate only the z. So the z, I have just z there by power, and I'm going to get 1 there. So I found those partials that I'm looking for. Next, next there we just have sine. So you have sine, then you have x squared minus y z, like that. So let us find the partials for this one. So partial of w, partial of x, what is this going to be? So you use chain rule, differentiate the whole function. So differentiating the whole function, I'm differentiating sine, so I get cosine. So this is going to be cosine. Then I write whatever is there, which is just x squared minus y minus yz. Then now I'm going, since it's chain rule, I differentiate the in function. So now that function there, I'm going to differentiate with respect to x. So I differentiate this part which has the x squared, and I get that this here is just going to give me what, 2x. And of course I can write this, writing the 2x in front, meaning I can write this as 2x cos, then this is x squared minus yz, like that. Okay, I do the same for next one, partial of w, partial of y. So it gives me the same thing, the function cos, then x squared minus yz, like this. Then I differentiate the inward one, that is with respect to y. Then I here see where there's y, differentiate the y here, you just remain with what, with z. So that gives you a negative z. In fact, you remain with a negative z there. So this here, applying the z in front, so the z is going to come here. Then I have cos, then x squared minus yz, like that is what I'm going to get. The last one is partial of that with respect to z. Then what am I going to get? The same, so I write cos x squared minus yz, like that. Then I differentiate with respect to what, to z. Differentiating this with respect to z, you see that I just remain with what, with y there, negative y. So like that, I write the negative in front, and I have cos, then x squared minus y minus c, like that. This is what I get. So those are my partials. Okay, this leads us to the last question now. So the last question, in here. So you have that this here is just w going to be, so you have cos hyperbola, that is cos hyperbola of, that is root. Here you have 3x minus y, then you have 5 z then squared, like that. So how do we do this one? So to do this one, I say partial of w partial of x, like that. I differentiate the whole thing. When I differentiate cos hyperbola, I just get this is going to give me sine uh, hyperbola. So this gives me sine hyperbola, which is just sine, the sine, the h there. Then of course, I've just differentiated the outer function, so meaning I can put back this here since it's the outer one, like that. Then next here I now have to differentiate the inward function. So the inward function, you see, is this root here, and of course you see that you can write this as x squared minus y plus 5z squared then to the power half. So I'm differentiating this now with respect to what, to, of course I'm still using the chain rule. So half there, if I differentiate, I'm just going to get the half would drop, then I subtract the what, a minus there. So I'm going to have half, like that, then multiplied by 3, then x minus the y plus 5z squared to the negative half, because I've reduced there by the power of 1. But you see that this now means that this is going to go down and it's going to give me a root there. So this is going to be 1 over the 2 there. Then because that has a negative, I can write it in a positive, where I just write it down in the denominator and have the square root there. Is going to be what, 3x, then minus I have y plus 5z squared. So this is what I get. But then I'm differentiating with respect to x. I am not done. I have to differentiate this again. Chain rule. So inside here I differentiate with respect to x. So I only differentiate this part here since I'm taking the partial derivative. So I differentiate 3x. I just remain with what, with 3. So to clean this up, so this is just going to look something like, I have a 3 there, then sine hyperbole of then I have root 3x minus the y, then plus 5z the squared, then there I divide by 2, then of course root there, then I have 3x minus y plus 5z squared. So this is what I'm going to get. Now notice that this part, for every one of them, every part which I'm going to do and this part is going to be the same. What is going to be different is the last part, which I'm going to be differentiating, because depending on what I'm differentiating with respect to. So for the next one, it means, so for the next one, I raise this. Okay, let me raise everything here. So okay, so for the next one, which is just the partial of w with respect to what, to y. So this here, then the same thing in between. So I have the sign like this. Then I have 3x minus y plus 5 what, 5z squared. Then I multiply this by 1 over what, 2 root the exactly what I had before, x minus y plus 5z just squared, like that. Then now I differentiate this, it's y. So the y, negative y here, I differentiate that, I just get negative 1. So writing this up nicely, I just get this will be negative sine, like that, sine hyperbola of, then I have 3x minus y plus 5z squared, then divide this by 2, then I multiply by the 3x minus the y plus 5z squared. So this is how I get, this is my answer for this one. Then okay, this leads us to the last part, which is with respect to what, to z. So I erase again. So with respect to what, to z. So here I also erase this. So I have partial respect to what, to z, like that. So what is this going to be? So the same thing here, we said sine, then sine hyperbola here of the 3x minus the y plus the 5z squared, like that. Then I'm multiplying here over 1, then the root here, the square root is going to come, 3x minus y plus 5 squared, 5z squared. So now here, notice that I have to differentiate this 5z squared. So that gives me what? That gives me 10. So this gives me 10z. So this gives me 10z. So I can divide there 1, divide there, I get 5. Clean this, write this nicely. I just get that to be 5z sine hyperbola of the root of 3x minus the y plus 5z squared. Close that, then I divide by, so that is gonna be the square root of 3x minus the 5 plus 5 z squared. And just like that, this is how I get those partials here, those partial derivatives. That's how I get them. Right, so if you're new, remember to hit the subscribe button, and I'll see you in the next one.